The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Okay, our next two speakers, they teamed speaking on this. We have Dr. Mohamed Mahgoub. He's a graduate from the Al-Azhar University, Cairo, Egypt. He received his degree in 1990 and his master's in 1997 and a PhD in 2004 from Carleton University in Ottawa. He's currently an associate professor in the New Jersey Institute of Technology. His academic studies, along with working as a structural and consulting engineer, has resulted in significant changes in the 2005 National Building Code of Canada, addressing many elements in the design of structures. Mohamed is a member of ACI Committee 342, Evaluation of Concrete Bridges and Concrete Bridge Elements, ASCE Earthquake, Earthquake Engineering Research Institute, and Engineering Syndicate of Cairo, Egypt. He also holds a PE in Michigan and a PING in Ontario, Canada. So, and his second speaker is Wayne Rawlins. He's currently a student at getting his degree in construction concrete industry management at the New Jersey Institute of Technology. He comes with us with 15 years of practical experience. In aspects of ready-mix concrete from the island of St. Kitts, including quality control plant, equipment, machine operations, and maintenance. Operations manager was his primary role. Wayne anticipates a May 2019 graduation, probably dependent on the talk today, working to blend his experiences with his degree in concrete industry management. So without further ado,
I don't need a microphone. I'm loud by birth. It's just I'm standing up here, so I have a bad knee, so I have to lean on something. I'm just going to talk for 5 minutes, I hope, because you don't give the professor the microphone and ask him to talk for 5 minutes. But and then after that, I'm going to leave the floor with for Wayne to talk about lots of data, because we did the research for this 90-minute rule. I am also the director of a program called Concrete Industry Management. I'm a structural engineer by birth. So I design bridges. I used to design bridges for Michigan Department of Transportation, and we used to hate that 90-minute rule. But I mean, the DOT over there, 90 minutes and 30 seconds, rejected. The people who are rejecting, they don't even know what 90-minute rule or what that grandma thing, and as we heard, the advanced knowledge in the admixtures that you can put the concrete to sleep for 24 hours. I'm a reviewer in lots of journals, and I reviewed a paper recently from New Zealand. They can put the concrete to sleep for 24 hours without changing its properties. So we're not talking about 90 minutes and 120 minutes. We're talking about 24 hours. So anyway, I was a member of the New Jersey ACI chapter at the time, 4 years ago. Now I'm the president, by the way, of the chapter, maybe because of this research. So I was sitting over there, and then Kaz Bugnaki, if you don't know Kaz, he's the chief, he used to be, he's retired right now, the chief material engineer for Port Authority. And they used to do the New Jersey ACI chapter, they used to choose research for the universities, hot topics. So they decided, Kaz said, what the problem we are getting, because we are in New York City and they were building the World Trade Center, that because of the traffic, we never get the truck after 90 minutes. I mean, this is a big argument all the time. So he said, we need to do research, to do real research to see the effect of 90-minute rule. We are going to do samples, and we are going to test them, and we are going to draw curves, and we are going to see that and this. And so we are going to give $20,000, which is, to be honest with you, nothing. But we had fund from our concrete industry management program which is a concrete degree offered all over the United States in 4 universities: California State University West, NJIT East, Texas State University South, and Middle Tennessee State University, the flagship university in Tennessee. So we said we are going to do it. So we applied, and it seems that we are the only university who applied because everybody was scared. We said we are going to do it. Especially we heard, even though that ASTM, I'm not quite sure, I see some members here from C94, that they had a try to do some tests about it, but it was not that advanced. So we said we are going to do it. So we started 4 years ago, and we went, we put, actually, there were, Wayne was on the head of the people, of the team, going. Larry Selvey provided the ready mix for us, and we did the concrete. We did, as you are going to see, we did a couple of mixes. One with the regular weather, one with the very hot weather, and we were planning to do one with the cold weather, as you are going to say. And then we submitted the report, and everybody received that report with like joy and happiness and stuff. And we have been asked to present. We presented in ACI New York, and we presented in ACI New Jersey, and we presented in ACI Eastern Pennsylvania and Delaware. And then we went even to the C94, and we presented there twice for 2 years, thinking that it's going to be a piece of cake. We are going to do that like this, and NJIT and everybody is going to be happy, and we are going to be like the kings of the world. And then after that, we found big rejection to this 90-minute rule. And I was like, why are people rejecting? And I kept like digging. I was thinking that they are still doing the balloting until now. We are talking about 4 years. We started the research 4 years ago. And I kept searching and searching and searching. And unfortunately, I found that the ready-mix people are against it. I said, excuse me, this is a big surprise. I'm saying it right now. Why? They said, because of now we are going to lose money. And instead of having 5-6 trips per day, you are going to make us having 3 trips per day. So the 90-minute rule, if it's going to become 120 or 150, the truck drivers are going to be lazy. And instead of making truck after truck after truck after truck, we're going to make less amount of trucks. And then we're going to make less amount of money. But the ready-mix people, as you guys saw, they were like, yeah, that's it for us. This is like breaking news. They were so happy. So the fight is between the ready-mix people and the admixtures people. But I mean, actually, even we heard that there is no even reason why there is 90-minute rule. So I don't know why there, I mean, nobody knows even what behind that. Is there any significant reason or anything? So we're gonna see our test right now, what we have been doing. And then some people came and they said, you guys did the test on fresh concrete. How about hardened concrete? So we got another grant, $50,000, $25,000 from NRMCA and $25,000 from PCA. They were interested, and we are doing now extension of that research on the effect of extended time on the durability of the concrete. So we're doing freeze thaw, we are doing permeability, we are doing other stuff, and we are gonna publish that soon. So that's what we are doing right now. So we are gonna satisfy all the comments we received from other people. They said, oh, okay, that's fine. This is for fresh mixed concrete. How about the other stuff? With no further talk, I would like to introduce my student, Wayne Rawlins. And Wayne actually he's a special student. He's with 15 years of experience in ready mix. So he knows this stuff by heart. So with no further ado, I'm gonna leave the floor for him. And then after that, at the end of the session, we're gonna have time for questions. Thank you.
Good evening, everyone. So, as the speakers before me have alluded to, the 90-minute rule is one of those rules that we keep asking ourselves, what's the basis behind it?
Yes, as I was saying, the 90-minute rule is one of those things that is outdated. But instead of just saying it's outdated, why not provide information to challenge it and to bring about meaningful discussion with the aim of bringing about meaningful change. So what I'm going to present is pretty much data on actual trials that we did. So we focused our research on 3 different mixes, 100% OPC, a slag mix, and a fly ash mix. And each batch was done twice to attain the specific results that we were looking for to present. The ready-mix concrete was supplied by Sylvie Concrete in Phillyville, Pennsylvania, and it was not a specific mix as some may think in terms of do you need to have a special mix to achieve these results? Our aim is to focus on the typical mix that, because you're going to have difference in materials, and you can achieve these results basically anywhere you go. So the design was on locally available materials. So you have here a picture of the batching plant at Sylvie. Now, one of the reasons that we chose to do a mix at the batching plant, we feel that if we do an actual site mix, it'll give it more credibility and more realistic results as opposed to doing a mixture inside of the lab. A lab mix is always going to give you quote-unquote perfect results. Our interest is in what is going to happen in the field, because what happens in the field is what determines a lot, and the outcome of your concrete is what affects the concrete, the performance, etc. So we chose to do an actual field mix at an actual batch plant. These are some of the tests that were done. We decided on doing timestamps of 60, 90, 120, 150, and 180 minutes to determine the effects and the performances of the concrete at those individual time frames. Typical tests: slump, entrainment, temperature, compressive strength, flexural, permeability. So in terms of the actual tests that are normally done on fresh concrete, we pretty much incorporated all of them so that we could have an array of results to present. Target properties, again, nothing strange, nothing unfamiliar. 28-day compressive strength, which is industry standard, max aggregate size of 1 inch, target slump, target air, hot weather conditions, moderate weather conditions, and your typical specimen size, your 4x8 cylinders for compressive strength, your 6x6 18, and your 4x4 12 for flexural strength. So again, nothing new, nothing out of the norm to say that anything specific or anything special has to be done in terms of preparations and fresh concrete to achieve the results of going beyond 90 minutes. Just typical mixes as typical preparations, typical tests, as you can see so far. Here you have a picture, again, proof that nothing special. Cylinder molds, your beam molds. Quality control, of course, is imperative. We made the determination very early that the only interference, the only adjustments we'll make is with the high range water reducer and the air entrainment. No water addition whatsoever would go into these mixes, because then you put in you add water to it, then you now have the change in the water cement ratio, and you could have further challenges that we want to minimize or not encounter. We utilize quality control reps from the supplier, and Seeker Admixture, they were on board with us, and they supplied representatives as well to provide guidance and so on. Like I said, we use the actual ready-mix plant, actual ready-mix truck, because we wanted to make it as realistic as possible, okay, so that it could be quite comparative. And of course, we use certified students and staff to perform the test. Here we have the fresh concrete being tested, taking your samples, making your slump. You have your typical air part, your temperature gauge, everything, representative of what goes on site in terms of testing concrete. And one of the things we did was microwave test for moisture content. Not a picture of a test being done. So, expected research outcome. Pretty much to determine that there's no loss in performance of the mixes when going beyond the 90 minute. And one of the things that was determined to be used is hydration stabilizer, because it has proven that hydration stabilizers and retarders sort of help the concrete to perform in the intended way that you want to go beyond the 90 minutes. Repeat performance of the concrete mix were done over 180 minutes at 30-minute increments, as I alluded to earlier, and then to evaluate the results at the end. Okay, here we have the samples already been made, ready to be transported and being cured in the curing room at NJIT. What I'm going to present now is some tables, showing the results from the test. So as you can see here in the slump during the hot weather, it was fairly consistent, especially when you take into consideration the use of the hydration stabilizers, which is these mixes with hydration stabilizer. You see, it's fairly consistent right here. So that is proof that utilizing hydration stabilizers sort of give you a fairly consistent slump, give you better slump retention. And here we have the same in moderate weather. So the first one previously was in hot weather, and these mixes we started in about August and we went down to in October. So to give you an idea again of realistic field conditions. Again, you have fairly consistent slump retention, especially using the hydration stabilizer admixture. Air. Air, of course, is a major concern because as the mix is extended, you can have a loss in air. And at different intervals, at each interval, when we tested the mix in 30 minutes, we will check the slump and air. Of course, all these tests were done. In some instances, which we'll see the results later on, we had to retemperate with both the high-range water reducer and the air entrainment. But generally, all things considered, the air was fairly consistent, again, when you use hydration stabilizer. So it's continued proof that utilizing admixtures is pretty much what's going to guarantee or assist you in achieving these results. Right? Air entrainment, again, during moderate weather, it's even more consistent when you compare to some of the mixes. Is a little erratic during hot weather, but in moderate weather, it's more stable. Temperature. This one was done, this is the hot weather graph. You have the average air temperature in August was about 97 degrees. Comparatively, you have the mixes here, hydration stabilizers. You have pretty much about a 6 degree temperature rise in all of the mixes with and without hydration stabilizer, which is not significant. Okay. And then if we go to moderate weather, again, it's fairly consistent. The cooler temperature, of course, is going to play a role. The hydration stabilizer helped to maintain it with an average air temperature of about 70 degrees leading into October. This graph has a little bit too much information, but in a nutshell, coming out of this graph is your strength results, which is the main concern of most individuals where the 90-minute rule is concerned. And it shows here that we pretty much hit the 6,000 PSI target strength regardless, both with and without hydration stabilizers. So again, doing this research enables us to present actual facts, not just, present actual facts to aid our speaking point that it's quite doable, it's quite achievable. Here we have it broken down a little bit. So this one was this is pretty much all of the mixes. This is hot weather mixes by itself. As you can see, the graph is not all congested. And we're hitting our targets. So this one, mix one, which is mix one, if you recall, was just 100% straight Portland cement. This one, hitting our targets. Mix two, in moderate weather, you're still hitting your target. Mix three, in moderate weather, hitting your target. And then you have one of the other tests done was flexural strength. So I want to focus a little bit more on mix two. Mix two and mix three, of course, the ones with fly ash and slag, show the most promise in terms of consistency and maintaining all the different characteristics that we're hoping for. So you have a range, mix two ranges from here. This one is a flexural test to here. So you see it's fairly consistent over the testing period of 60 minutes down to 180 minutes. Here we have the mixes showing flexural strength in moderate weather, no hydration stabilizer, and you have mix two between here. Again, flexural strength, 56 days with hydration stabilizer this time, and you see how fairly consistent it is. So the results pretty much are showing that, you know, there's no impaired effect on the effects on the concrete. You have your permeability test. As you can see, reduced permeability when you incorporate these supplemental cementitious materials. Same thing here, 90 minutes in hot weather with hydration stabilizer. You have the results between it. Again, fairly consistent. Okay, this one is 90 minutes in moderate weather with hydration stabilizer. So that was the last of the charts. So the summary of the findings. The summer pause basically, as expected, the walkability was not going to be as long as in moderate temperature. We pretty much had to redose with stabilizer and high-range water reducer at about, I think it was every half an hour. In the case of the 100% Portland cement, we actually did it twice to get a more average result and to determine, you know, the effects again. So the slag, as you can see, the slag and fly ash, it was workable up to 150 minutes. The 100% cement, not so much. Pretty much started setting up much earlier. All of the mixes, our control sample was the 60-minute sample. So the 60-minute sample acted as a control for all of them. The 100% up to 100 minutes, after that it started setting off, the slag and the fly ash was workable enough up to about 150 minutes. And this was no water whatsoever. No water was added at, sorry? Mm-hmm.
What do you redose at here?
Oh, high-range water reducer, Super P.
Okay.
Yeah. The only addition we made to any of the mixes at any time were air entrainment, admixture, and Super P.
I mean, I got a question.
Sure.
This was a 6,000 PSF mix, correct?
Mm-hmm.
So it was already mixed with a slump or rain that was retaining through superplasticizers to begin with?
Yes.
Okay. So we're seeing the effects of plasticizer.
Well, naturally it will. The lifespan of Super P, you know, is about 45 minutes, give or take, optimally.
Chemical slump, water slump. Kind of two different things. Yeah.
Well, because of the shrink, you had to incorporate, you know, water reducers. The specific water-to-cement ratio, I don't remember what it is offhand. Again, it was not like a special mix. We just used a typical mix. So if plant A has a 6,000 PSI mix that they supply, we'll run with it. If plant B have their specific, you know, their particular mix design, we'll run with it. The goal is to prove that you don't need to have anything special per se to achieve those results.
So is it safe to assume that if you had a redose, you would have lost slump?
Well, the reason for redosing is because of reduction in slump.
No, that's what
Yes.
So
Yes.
basically, if you had a redose, there's no way you could have made it out to 180 minutes.
Correct. Correct.
So in that case, is it, how can you say then that the hydration stabilizer is working?
Well, we're gonna look at some additional results further down, and you'll see that again temperature plays a role. If you previously during the summer, the average temperature that we tested, the average air temperature that we tested on days that we tested were like 97 degrees, which is pretty much on the hot side. During moderate temperature conditions, you see that the effects were further extended.
I mean, typically with hydration stabilizers, you know, once you add them, you don't have to do anything, and they're able to hold the slump over the duration that you're looking for. So if you have a situation where you have to redose, you know, then I would say the hydration stabilizer is not working. Or it's not a true hydration stabilizer.
Take into consideration, again, this is the first.
Something that he's saying shouldn't have necessarily needed a redose of plasticizer.
Yeah, exactly.
So, did you use the set dosage of superplasticizer for everything?
No, it varied. Again, we take into consideration the input from the admixture suppliers. One of the things to take into consideration is that this was our first phase. So it was a trial, you know, it was a trial approach. So going into the next stage, we will have already developed results and have a better idea of the dosage to use going forward. If that answers the question. This was our first try, basically, our first foray into the research in the 90-minute rule. So going forward, we have a better idea as to what dosage rates will more closely reflect what it is, the desired outcome. So yes, generally when you establish data and you have historical performance, you will know what dosage rates to use. Like, for example, from my experience back then, we already know what dosage rate of retarder we'll use depending on, what type of job we're pouring, where we're going and that sort of stuff, because I already have the historical data. Here we are just developing it for the first time and we're going to build on it. So a lot of the questions that have arisen and will arise where this is concerned, we'll be answering them as we go along in terms of making additional tests and presenting the data. Well,
I think what the big concern is that Charles and Scott are getting at, which I understand. The concept is, let's get rid of 90 minutes. And somebody states whatever time that is. Purchaser now states 180 minutes. Okay? I don't know if you guys are, but in the Southeast, it's tough to find QC techs. So the last thing that you want to do is to have your QC techs tied out of jobs, having redos. The concept is getting that mix to target a slump over the time purchase, and then understand at the end of that, now let's say theoretical 180 time period, purchaser stable, that the impact on all of the other things throughout that life cycle without a redose works out. Maybe it's a hydration stabilizer. I can tell you that in our area at 98 degrees, likely may not work to maintain slump within 1 inch of patch slump at 180 minutes. Okay? It may take something like a slump extension. Okay? Admix. Not here to sell admix. Just making a statement based off of data in our market that I'm not aware of. So I think that's a big thing to understand. We don't want to get into the business and have our customers get into the business saying, hey, this is great, just keep adding admix every 30 minutes and you need to maintain something.
good. Now, if I... Okay. Next slide here is a continuation of a summary of the findings. The fall pour without a hydration stabilizer, as you can see, compared to during the summer, we pretty much were only able to get up to 100 minutes on the 100% OPC. We were able to get up to 180 minutes without hydration stabilizer in moderate weather. So again, I don't know if that answers some of your question. Fall pour with hydration stabilizer, all the mixes were able to get, achieve good workability up to 180 minutes. The compressive strength, again, we are able to hit our targets where compressive strength is our concern. The mixes with hydration stabilizers pretty much yielded higher strengths regardless of, conditions, atmospheric conditions. Flexure test, the data, as it says here, the concrete mixes were stronger during hot weather, which we didn't quite expect that, but is what the outcome was. And that with a hydration stabilizer, I think you asked the question about control mix. Again, the 60-minute sample is what, so that's the control. Flexural strength was about target 10-11% of your compressive strength at pretty much all the discharge times. Permeability, as you can see in the previous charts, permeability was good. It was not affected. It was within acceptable ranges. And the ones with a hydration stabilizer had pretty much had the slightly lower permeability results. Now, the one with the mixes without hydration stabilizers, they started setting up pretty early, and the ones with the hydration stabilizer, gave us the extended times, and this last one pretty much extended here. We had to redose with ear entrainment on a couple occasions. Okay, so that brings me to the end.
Thank you for a thoughtful presentation. It was very, very well done. Thank you. For those in the back of the room, I'm curious, the initial setting characteristics of concrete versus the wear-off of superplasticizers, they're the same, but they're very, very different. You don't have any real data except for temperature increase to know which is occurring. In your research, could a redose of a hydration control stabilizer be done once the material is gained in strength, or is that not possible?
It pretty much will not have much of a positive effect after it's already started setting up.
So its initial invention and creation was done to return old concrete back and reuse it. Its effectiveness is not good once the chemical reaction begins, is that correct?
Exactly. Which is why you have to utilize that mixture to slow it down or prevent it from getting there sooner.
Very good. Aside from temperature rise, is there any other indicators that indicate that we're having the initial setting characteristics rather than, as you perfectly said, that the hydration control or with superheat tend to wear off in 45 minutes, regardless of the
Well, again, modern development, modern technology / chemistry, is improving the performance of high-range water reducers. So it's about 45 minutes now, give or take. Previously, it was even less. So, thank you.
We're going to hold questions, so please.
I need to say something before this. I need to thank lots of people, guys, that helped us with this research and even helped us to deliver it to the people. Starting with ACI, New Jersey chapter, Kaz Bugnani, who came up with the idea, Zach Rich, who was the president at the time in Silky Concrete. I'd like to thank NRCA, people Coulomb and Dr. Coulomb and Julie Garbini, who gave us the 50,000 extension to continue that research and to refine the material and the findings. Colin actually is with C94, and we have been in touch since we started this research, getting the feedback and going back and forth, and he allowed us twice to present over there. I would like to thank PCA, actually, Michelle Wilson, she was here earlier, and Steve Konkatska and Kuzmatska. And they were all the time, actually, we got the 50,000 from NRCA, and PCA said, no, we would like to have this, we need to get to the bottom of this thing. So as you can see, we are trying to refine our methods, and we are still doing it again, and we are going to hit Larry Silver again, we are going to repeat the whole thing again from the beginning, and we are going to take care of all your comments and the comments we got from C94. And we are going to take it further by doing the freeze thaw. We bought a freeze thaw machine, but unfortunately they delayed it until November. We are going to get it by the end of November, and then we are going to do the freeze thaw as well beside this stuff again. So thank you very much for attendance. I didn't expect this big attendance, and I really appreciate it. Thank you very much.
Thank you.